Today I'm talking about the key features of rational functions again. We are going to be looking into what are called horizontal asymptotes or slant asymptotes. And you cannot have both of these, it's either one or the other. And all rational functions are going to have either a horizontal or a slant asymptote. So how you can determine which type of asymptote you'll have for your rational function is you have to determine where the higher power is. If the larger degree happens to be in the numerator, so that means it's in the top part of their fraction, like x cubed plus 2x divided by 2x squared plus 1. So my higher degree is in the numerator, then it is going to be a slant asymptote. But if instead you had the higher degree in the denominator, so let's say I had x plus 3 here, and this was x squared minus 7x plus 3. So my larger degree is in that denominator. Then it is y equals 0. Oh, and when you have a slant asymptote, you're going to have to divide. So that long division we did a couple of chapters ago is going to come back into play for the slant asymptotes. When the higher degree is the same, so that means we have the same power in both the numerator and the denominator. Like, let's say, so our highest degree is the highest exponent in both the numerator and the denominator, so that's squared. What you're going to do is you're going to create a reduced fraction, and our slant asymptote is going to be the coefficients in front of your highest degree reduced as a fraction. So 2 over 4, which reduces to 1/2. So my slant asymptote is at y equals 1/2. Or my horizontal asymptote is at y equals 1/2. So let's go ahead and work a couple of these problems. So we're going to first off determine, is this a horizontal or a slant asymptote? And then we are going to find that asymptote. So if I look at my highest degree, there's nothing stated, so that means it's 1 over 1. So they match. That means I need to look for my leading coefficient. So if they match, that means I have a horizontal asymptote. And now looking at my leading coefficients, so I know it's horizontal, and my leading coefficients reduced. So 2 over 1, so my horizontal asymptote is 2. Now, let's do the same thing, but with a new problem. So let's look at problem 2. First question we need to determine, is it a horizontal or slant asymptote? And the way we determine that is look for your highest degree. And so the highest degree is in the denominator. That means that we have a horizontal asymptote, and there's no calculations. It's y equals 0. Now we are looking at this one to determine what type of asymptote we have. And so when I look at the highest degree, it is in the numerator. That means that we have a slant asymptote. When we have a slant asymptote, that means we are going to have to divide to find out what that asymptote is. So we're going to use our box to help us divide. And when we use our box, that means that we have this negative 3x squared is going to go here. And our x minus 1 goes here. And then you're looking at solving these one at a time. So negative 3x squared divided by x is going to give us negative 3x. Multiply gives me positive 3x. So negative 3x, positive 3x plus what gives me, and I'm looking for this x term in that numerator, and that term in the numerator is going to be 0x. So that means I need to have negative 3x. Negative 3x divided by x gives me negative 3. Negative 3 times negative 1 gives me a positive 3. 3 plus what equals 2? So that'd be a negative 1. And so my remainder is negative 1. But like I talked about earlier in the video, we're going to ignore the remainder, and our slant asymptote is going to be what was left. And so our slant asymptote in this case is y equals negative 3x minus 3. And what that means is as I graph this is going to become asymptotic to this line. And so you would have a dashed line of negative 3x plus 3 graphed. And just kind of refreshing how our brain, making our brains think about this is going to be your y-intercept for the asymptote, and this is your slope. So I want you all to do this next one on your own. So first off, I want you to determine what type of asymptote is it. Is it a horizontal or slant? You should have found that it was a horizontal. And what is the asymptote? Well, they're the same degree in the numerator and the denominator, so that means that our horizontal asymptote is that y equals negative 2 because that was the reduced fraction.